Hello. Today we are going to look at antiderivatives with initial conditions. Now, remember, antiderivatives gives us a family of functions. We have a plus c. Initial conditions will restrict that down to a single member of the family. And so we'll see how that works here coming up. Suppose I have f of x is equal to 4 cubed root of x minus 3 divided by x. And this is, I want to find the antiderivative. Find capital F of x given, this is the initial condition, capital F of -1 is equal to 5. So the first thing I need to do is find the antiderivative. Before I can do that, I need to do some algebra. So actually, let me just go over here. F of x is equal to 4 cubed root of x minus 3 over x. This is equal to 4x to the -2/3 minus 3 over x, doing some algebra. And then at that point, my capital F of x is going to be 4 times, add 1, I get x to the 1/3, reciprocal 3, minus 3 natural log absolute value of x. Remember, this is not reverse power rule, plus c, or then 12 cubed roots of x minus 3 natural log absolute value of x plus c. If I just wanted the antiderivative, this would be done at this point. However, I now use this initial condition. The initial condition says capital F at -1 would be, when I substitute -1, this becomes -12, this becomes 0, and so I just get plus c, and we're told that that is equal to 5. Well, because of that then, that means that c would have to be 17, which means I now get a specific member of the family. The actual end result in this case is going to be that capital F of x is 12 cubed roots of x minus 3 natural log absolute value of x plus, 17. This is my final antiderivative. A specific member of the family. Let's look at another example. Suppose I have f double prime of x is equal to 2 over the cube root of x to the 4th, and I'm given f of 1 is equal to -3, and f of 8 is equal to 5. Now, again, I can't remember if I put this in the video yet or not, but we basically have this ladder of derivatives. If I start off at f of x and I go this way, I get f prime of x, f double prime of x, etc. If I go the opposite way, I get antiderivatives. And so basically, to go from f double prime of x to f of x, I need to take 2 antiderivatives. So f prime of x would be the antiderivative of f double prime. We're going up, antiderivatives. And let me rewrite this. This is 2x to the -4/3. And so therefore, f prime of x would be 2 times I'm taking the antiderivative of this, add 1 to your exponent, reciprocal, plus c, or negative 6 x to the negative 1/3 plus c, which means that f of x, the antiderivative of that would be add 1, take the reciprocal, the antiderivative of a number, c, is c times x, and I still have another constant, in this case, d. And so then I get negative 9/2 times the cube root of x squared. I could have left this as x to the 2/3. Either way is fine. Plus cx plus d. I changed it because I'm going to put in a numbers. And now notice I have two variables here, two values c and d. I need to deal with. That's why I have two initial conditions, because I had to take two antiderivatives. F at 1 is going to be negative, oops, this is not negative 9/2, negative 18/2, which is just plain old negative 9. Glad I caught that right at that moment. This is going to be negative 9 plus c plus d, and we're told that that's equal to negative 3, which means c plus d is equal to 6. And f at 8 is equal to, the cube root of 8 is 2, squared is 4, so that becomes negative 36 plus 8c plus d, and that's equal to 5, which means that 8c plus d is equal to 41. So I now have this system of equations that I have to solve. And if I just take my first one, and let's suppose we multiply by negative 1, negative c minus d is equal to negative 6. The first one, and the second one, 8c is plus d is equal to 41. Use elimination. 7c is equal to 35, so c is equal to 5. And since c is equal to 5, that means that d is equal to 1. And so, final result, which I guess I will write right down here, f of x is equal to negative 9 cube roots of x squared plus 5x plus 1, incorporating the values for c and d.